So at the bottom of page 1 of 7.1b, we're looking at some examples where the instructions say, factor each polynomial using the greatest common binomial factor. We're going to take our knowledge of greatest common factor and now realize that we're looking for a two-term factor. We're looking for a big factor that they have in common. Just like we did in the what if example up further on the page that we just finished in the last clip. So looking at page 420, number 52, this example right here, we have x times the quantity x plus 3 minus 8 times quantity x plus 3. This 8 is like the term separator here. Here's our first big term on the left and our other term on the right. And we're looking to see what these terms have in common. It's almost like you kind of zoom out and see the big picture here. The x plus 3 is the same in both of these. So that becomes our GCF. And again, we're going to get really good at this because we always check for the GCF first. And so our GCF is equal to x plus 3. So that's what gets pulled out. So when we factor this, we pull out the x plus 3, and then what's left behind is what was being multiplied by those things, the x and the minus and the 8. So the x plus 3 was what the two sides had in common. Bring that out as the GCF, and then write what's left behind. Very similar to what we did with GCF, only now the GCF feels bigger, okay? Now, one of the things we're going to also train ourselves is every time we pull the GCF to ask ourselves how many terms are we leaving afterwards. And in this case, we've got 2 terms here, but it's not a special case. It's not DOS, difference of squares, DOC, difference of cubes, SOC, sum of cubes, and of course there is no formula for sum of squares. So it's not a special case, so we're done. The factored form of this, and you can expect at the beginning that they're only going to have you do this one piece to get used to it. The done version, the factored form is x plus 3 times x minus 8. Okay, and again, you can check by refoiling this or redistributing. Notice that it would probably take you even further than this original spot because they're just hand feeding this to you right now just to get the practice of pulling that bigger looking GCF out. Okay. Now, what's different about this next example? Look at page 420, number 58, written right here. 5x times the quantity 2x plus 1 plus 2x plus 1. What are some things you notice that are different? One might be that in these other examples, we've had the same item in parentheses. 2 sets of the same thing, both in parentheses. In this new example, there's only 1 set of parentheses. But as you read it out loud, look at it, you can see that that same item, the 2x plus 1 that's in the parentheses on the left, is also over here on the right. There's just no parentheses. So if it helps you to kind of view this, think of that in terms of being in its own set of parentheses, and it's just being multiplied by 1. When it's just sitting there by itself, it's as if it were being multiplied by 1. The first set is being multiplied by 5x. Second set, essentially it's being multiplied by 1. Let's rewrite that so it looks just a little bit clearer for us and more to what we're used to practice this part. So you might want to write it like this: 5x, parentheses 2x plus 1, plus 1 times parentheses 2x plus 1. And if you haven't noticed so far, those of you taking advantage of watching the video lessons, I strategically pick examples to do together on the page that not only help introduce and explain a concept, but I also pick ones that I think might trip you up a little bit in the homework, might need to cause you some extra thinking. So push yourself a little bit when you see these on the notes, and maybe see if you can tackle them even before I try them, before I do them for you. That's why I throw the tries in there, but there's also some along the way, the what's different, that will help you get stronger too. Okay, so the GCF in this case is the 2x plus 1. This is what's the same on both pieces. So that's equal to the GCF. So that's what we pull out front, 2x plus 1, and what's left behind is the 5x and the plus and the 1. So the 5x plus 1 is our second piece. Okay? So this represents the GCF. This represents what's left. And in this case, we ask ourselves how many terms? Because that's our process here. There's 2, but it's not, again, it's not a special case. It's not difference of squares. It's not sum of squares. It's not difference of cubes. I'm sorry, it's not difference of DOS, DOC, SOC. Difference of squares, difference of cubes, sum of cubes. There is no formula for sum of squares. Even if it was one, you couldn't go further. There's no way to factor that back out. Okay. So our finished version here is 2x plus 1. We're done factoring. Sorry, that D kind of went wild here. Done factoring 2x plus 1, 5x plus 1. Okay. So take a moment, make sure you've had a chance to copy this down, note any questions you need to bring to class, and also take a moment to talk it through, either with somebody or just out loud to yourself, what you've seen, what's happening. It's time to start internalizing so that you're really, really solid for the test. The way you prepare for a timed test is you get so good at this. You know it forwards and backwards. One of the ways to get really good at it is to rehearse it out loud, practice it on paper over and over and over again until it becomes a natural habit. And there's no hesitation when you get to the test. Okay? So here's one for you to try. Pause the video, try number 54 on your own, come back and check your answer in just a moment. So the finished factored version of this one is y plus 9 times x minus 11. The GCF they pulled out was y plus 9, leaving behind the x minus 11. X minus 11, 2 terms that don't match any of the special forms, DOS, DOC, SOC. Of course, SOS, S-O-S, doesn't have a special formula that you can factor into. So we're good here. Now, some of you might ask at this point in the game, does it matter which order the factors come in? No. You could rewrite this as x minus 11 times y plus 9. In other words, just switch spots with these. Totally fine. That means the exact same thing.